What we're going to talk about right now is a multi-step molar conversion that involves actually solving two different problems in one question. So if you look at question number 5 on your multi-step conversion worksheet, reading along, an oxygen tank contains 4.5 times 10 to the 22nd molecules, so that looks like that could be some given information, so I'm going to circle it. How many liters of oxygen gas are in the tank? How many grams of oxygen are in the tank? These are two different questions. How many liters of oxygen gas are in the tank? How many grams of oxygen gas are in the tank? So first I'm going to solve this one, and then I'll go back and solve this one. Okay. So either way, starting point is going to be 4.5 times 10 to the 22nd molecules of oxygen over 1. And the first question is saying, let's go from molecules to liters. So we're going to look at our mole roadmap. Well, a molecule is a particle. To get from a particle to the mole, you have to use 1 over 6.02 times 10 to the 23rd particles. To get from a mole to volume, we have to use 22.4 liters per 1 mole. So we're going to just go one step at a time, times 1 mole. We're going to get our molecules canceled out here. Molecules on bottom. And then multiply that times our volume relationship, which we looked up on the roadmap. Okay, and then it ends in volume, liters. So we know molecules cancel and liters, we're going to end up in liters. Moles cancel. Sorry, so this is actually liters is what we were trying to find. So that's what we're going to get into. So molecules cancel out and moles cancel out. Now we just have to plug this into our calculator. So remember, when you're plugging in, see this, that we want to do parentheses on top, 4.5 E22 times 22.4, so everything that's on top, 4.5 times 10 to the 22, we don't have to write 1 because it's just going to give us the same thing, times 22.4, and then we divide by Avogadro's number. So there are 1.67 liters of oxygen gas in this tank. Alright, one more step to get this second question here. So we already converted into moles. We went from particles to moles. And then, so this step right here, we can kind of continue from there. We're already in moles. What we need to do now is get from moles to mass. And this is probably where it's going to be easiest to make a mistake, because to get the molar mass of oxygen, we have to watch out for one little thing. And that would be the fact that oxygen is a Hofbrinkel gas. It's a diatomic. That means that in its natural state, oxygen looks like this. It's O2. So the molar mass of oxygen, which we decided goes on top, it's molar mass over 1, is going to be 15.99 times 2. So when you plug that molar mass in, you have to multiply by 2 because it's a diatomic. Alright, so same thing will cancel molecules, moles, and then we're going to have grams left on top. So this is our ending 1, and then down here we're going to have our ending, so this is answer to number 1, and then this is 2. It's going to be 4.5 times 10 to the 22nd times this number in parentheses. Divided by, in parentheses, Avogadro's number. And you get 2.39 grams of O2. So this is our second ending.